here we have a question on beta and gamma function, where we will evaluate the integral by using the different properties of beta and gamma function and the definition of beta function. So for you, we have integration from 0 to infinity x raised to 8 in bracket 1 minus x raised to 6 whole upon 1 plus x raised to 24 dx. Now the question is how to evaluate this integration. So for that, let's understand the definition of beta and gamma function. So guys, here you can see the definition of gamma function and beta function. So if you'll see the formula number 1 and 3, then these two formula have integration from 0 to infinity. Now the formula number 1 is of gamma function, where we have one term as exponential and other term as algebraic, whereas in beta function we have both the terms as algebraic terms. Now if you'll see our question, then in our question we have all algebraic terms. So here, since we have all the algebraic terms and limit is from 0 to infinity, we will use the definition of beta function to evaluate. So this definition says that if integration is from 0 to infinity x raised to m minus 1 upon 1 plus x raised to m plus n dx, then it is given by beta m comma n. Now guys, here in numerator we want x raised to some constant, and in the denominator 1 plus x raised to constant. Now in our question we have 1 plus x raised to constant in the denominator, so in the numerator we should bring x raised to some constant, and for that what we'll do is we'll multiply this bracket with x raised to 8 term. So here I'll say let I equal to integration from 0 to infinity. This will become x raised to 8 into 1, that is x raised to 8 minus x raised to 14 upon 1 plus x raised to 24 dx. Now to match it up with the definition of beta function, we will divide the numerator separately with the denominator. So here we'll get I as integration 0 to infinity x raised to 8 upon 1 plus x raised to 24 dx minus integration from 0 to infinity x raised to 14 upon 1 plus x raised to 24 dx. Now guys, here we got the form which is exactly matching with the definition of beta. So the power of x is 8, which is equal to m minus 1. So it means the value of m minus 1 is 8. So it means m is 9. So here I can say that this is equivalent to 9 comma 15. So see here how we got this value. So since it is 8, this can be 9 minus 1. So m is 9. And if m is 9, then n must be 15, because 9 plus 15 is 24. So here we got beta 9 comma 15 minus, here let's apply the same form. So power is 14, so 15 minus 1 is 14, so m is 15. Since m is 15, then n must be 9, because 15 plus 9 is 24, so 9. So guys, here we got beta 9 comma 15 minus beta 15 comma 9, which is equal to 0, because we have one more property that says beta m comma n is always equal to beta n comma n. So by this property we'll get the value of integration as 0. So here we have seen the definition of beta, which we have applied to get the value of integral. So guys, I know that you like this video very much and you want to watch other videos, and if you want to learn more concepts about beta, gamma and the other chapters of engineering mathematics, then do log into ekida.com today itself, and you can also follow us on Facebook or Twitter for more updates about engineering mathematics. Thank you very much.